What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today is very, very, very exciting. And I want to tell you why for a couple of reasons, okay? So first of all, unrelated to what's about to go down today, to what's about to go down right now, because what's about to go down right now is super cool. But before I talk about that, we're doing a video later today to unbox this, which is so cool. Okay, so we just got the 100K plaque, and I'm really excited about it. I'm going to talk more about it during that live stream when I actually unbox it, so you can see that then. But it's a pretty cool day, so I'm excited about that. And then let's talk about what we're about to do right now. So for everybody prepping for the SAT this Saturday, especially the digital SAT in particular, but also the regular SAT, we got some new material today. And if you guys watch this channel a lot, you probably know that's what I love, is I love the new material. I love seeing a test for the first time. And hey, what's up, Ankit? Yeah, I'm good, man. Okay, so so basically we get to do this practice test right now together for the first time live in real time, which is awesome. And it's not only, look, I don't partner too much with anybody, and this kind of fell in my lap, to be honest. Checked out the platform from this company. It's called the SAT Crash Course. You can see the URL at the top. And I really like what they do. I really like their practice tests. I think they have really good quality, and it's not always easy to make these feel real and authentic like the College Board, and I think they've done a terrific job. And if you look at the interface too, it looks great. So we have partnered. This is a sponsored video, and if you do want access to these extra digital SATs before this test on Saturday, you can check the description, and there's a link in there to buy it, to go and purchase the test. And then you can also use the code SCALAR, all caps SCALAR, just like Scalar Learning, right? You can use that and you'll get 10% off. So if you want that discount, and if you're interested in additional good quality practice tests, this is the place to go. And now, without further ado, let's jump in and let's take this practice test. So right now, I'm just like kind of chilling in the reading and writing section. We're not going to really do it. We're just going to skip through all this. And we are, wait, hold on. Okay, good question. So Nadia asks, is the content the same? Okay. For the most part, yes, it's the same math content. The questions are very similar, etc. What I would say is there's some stylistic differences that I'm noticing as we're seeing more practice tests from the College Board. And okay, if you want to get into the nitty gritty, like for one example would be the C over A, shortcut formula, which is the product of the, I think it's I can't remember for sure now because darn it, but it's I think that's the product of the product of the solutions for a quadratic is C over A. That's not really used on the current version of the SAT that much. I mean, I barely ever see it, to be honest. I have seen that on the digital practice test. That's one example of like, it's within the realm of possibilities of what could show up on the current version, but doesn't really. And so now it seems to be something that they're throwing in, stuff like that. So I'm saying on the really difficult problems for the digital SAT, that's what I'm noticing. So I would say, if you look at the scope of difficulty, and again, what's up, Khan? What I would say is, if you look at the full range of difficulty, I think that the digital, again, this is just a sort of an assessment based on the practice tests that have been released. But it feels like the difficulty is a bit easier than the easiest question of the current version, and then the hard ones are a bit harder than the current hardest version. So that's my take on it. And then there's also little tricks that I'm noticing that are embedded in the digital that don't exist in the current version, like changes of units, just little verbal tricks that are going to take some getting used to. But other than that, for the most part, yes, I think they're very similar. Okay. Without further ado, we're going to jump into the mix right now. And, oh, hold on one second. Oh, 1 second. My assistant's here. I'm just going to open the door, and then we're going to start. Give me 2 seconds. Hey, I'm going to jump back on the stream. All right, here we go. we're going to start in right now, and I've got a little whiteboard here where I'll write notes and stuff like that, because you can't really annotate on the test, and that's it. So we're going to start in 3, 2, 1. Let's go. What is this? Okay, here we go. Should I zoom in a little? All right, beautiful. So question 1. And by the way, we're taking this test in real time for the first time, as I like to do. So z equals 7. What is 5? Okay, so plug and chug. 5 times 7 minus 15. That's 35 minus 15, and we get 20, right? You can use the calculator as well. Remember, the entire test is calculator. And look at this. You click on that, and it pops up, just like the digital SAT. So you can plug and chug if you want. I like to do it mentally. Boom, done. Let's go to the next one. This list gives the value of data sets A and B. Which statement correctly compares the range? Okay, first of all, let's look at the range. Range is the difference between the biggest value, max, and the min, right? So range of A is going to be 10. Range of B, 12 minus 1, is going to be 11. So we know B is bigger. A is less than the range of B. B is the winner. Let's just double check. Equal. Nope. There is enough information. It says all the values. I'm just making sure I didn't miss anything. Let's get 11, 10. Yeah. All right. We're good to go. Boom. Number 3. Two similar isosceles triangles. Hold on. Let me do this. Isosceles means two sides are equal. At least, actually, technically, it could be equilateral. Where W corresponds to Z, X and Y are the base. Okay, so it says X and Y are the base angles. And hold on, W corresponds to Z. So W corresponds to Z. So then this would be A and B. And they're similar, meaning they have equal angles and proportionate sides. If the measure of angle X is 50, what is the measure of angle B? It's also going to be 50 because, okay, if these are isosceles and that's a base angle, it says X. So those are the two that are equal. That's what it means in isosceles triangle. So those are 50, 50. These are equal. So these are going to be 50 and 50, and then up top would be 80. Not that that matters, because all we want is angle B. Angle B is 50. That's how you do it. Oh, they don't even have an 80 option. Interesting. Okay, 4. The car was refueled with 12 gallons of gas for a 240-mile trip. After driving exactly 120 miles, there were 5 gallons in 120 miles. On average, how many miles per gallon? That we already got it. So miles per 5 gallons, that would be 24 miles per gallon. You just divide. Again, pop open the calculator if you want. I just know that one. Wait, hold on. Let me just make sure I didn't misread it. Fuel 12 gallons. Okay, after driving exactly 120 miles, there's 7 gallons, so that's 5 gallons. And then, yeah, okay, we're good. Next, the solution to given system is, okay, 3x plus y. All right, let's take, okay. This is an amazing one because the College Board loves to do this. So I can solve this system, and I can get x, I can get y, and I can plug and chug. But sometimes they give you a little layup. Oh, wait, did they give us a layup? Hold on, negative, that would be... No, okay, it's not. Never mind. I thought we could get 3x plus y, but just by combining it, by negating this. But no, you get 3x minus y. So that wouldn't work exactly. Never mind. Okay, we're going to solve it the typical way. So let's eliminate, let's solve for x first. So I'm going to multiply the top by negative 3. So we get negative 18x minus 12y equals negative 72. The bottom one by 4, 36x plus 12y equals 4 times 3 is 120 plus 36, 156. Okay, so that's going to give us 18x. That's going to equal 72. What is that? 84. 84, right? And, oh, it doesn't go in exactly. Are you kidding me? Hold on. Let me just make sure I didn't make a mistake. 84 divided by 18. Let's just write it out or do it here. 84 divided by 18. 4 2/3. That's annoying. Okay, so 4 2/3. And then we're multiplying that by 3. Oh, we have to get y. Hold on. Let me get y here. So 6 times 4 is 24. 2/3 is 4. So that's 28. Negative 4. Negative 1. So y is negative 1. Okay, so I just got to do that mentally, but I just plugged and chugged. I plugged this in for x here, and I calculated it. So y is negative 1. So 3 times that is 12 plus 2/3 of 2, 12, 14 minus 1, 13. So the answer should be 13. Hold on. Okay, we do have a 13. Oh, another thing you can do. See, I forget that we get Desmos. Another way to solve this, and I'll use this to double check anyways, because those numbers were not the best. 9x, here, watch this, plus 3y equals 39. Okay, we can just straight up find their intersection point. That is correct, right? 4 2/3 and -1. And then you can do 3 times that. Here, I guess let's do it anyways. 3 times, we'll just approximate, and it's basically 13. So, yay. All right. Got to remember to use Desmos more because it's such a great tool. Okay. Number 6, chef uses, hold on, 280 grams. Sugar for dessert. Okay, blah, blah, blah. Where X is the number of small size, Y is a large size desserts. Okay, how many more grams of sugar does each large size have than each small size? So this is interpreting a linear equation, and basically what you have to deduce is it's 8 grams per small, per X. 16 grams per large is what is implied by the equation. So more, it would be 16 minus 8, which is 8. Okay, square A, we got a square, so let's draw it out. Always draw out the diagram when they mention a geometric shape. Square A has side lengths of 9. The perimeter of square, so this is A. Square B is 4 times the perimeter, which means each side length is 4 times those side lengths as well. Okay, it's 36, yeah, that's it. If the perimeter is 4 times, that means each individual side length is 4 times. Not the case if the area is 4 times. That's another deal. Wait, hold on. Let me make sure I didn't misread this. Perimeter square B is 4 times perimeter A, side length of one side. Yeah. Right? 36. Yeah. Okay, we're good. Number 8, given function f models the available seats in theater, d days are, okay, according to the model, how many seats are initially available? It's a y-intercept, it's 150. That's it. Know your linear equations. Know that that's the y-intercept, that's the slope, okay? And that's that. So if they ask for rate of change or how many, whatever, I don't know, whatever this represents. But anyways, initially available before the promotion. Wait, let's make sure we didn't. Available seats D days after, yeah. So after so that means they're giving away 2.5 seats per day is basically what's happening. Okay, 9. They want x minus 2. All right. Yeah, and so here, what should we do? Should we just solve for x? Let's just solve for x. Just don't forget we have to do x minus 2. So that is negative 3x plus 6 equals 210. And then you split the absolute value into a second equation where it equals the negative of that. Negative 3x equals 204 divided by negative 3. What is that? 68. Negative 68. But that's the negative value, so it doesn't matter. And then here it would be negative 3x equals negative 216. I know divided by 6 is 36, so it's 72. 72, but then it's x minus 2, so it's 70. Okay, hold on. Let's plug it back in and make sure. We'll use the calculator. Negative 3 times 72 plus 6 is negative 210. Absolute value is positive 210. So 72 is correct. And then 72 minus 2 is 70. All right. Next. The given equation relates, hold on. The positive numbers P, Q, R, S, which equation correctly expressed as Q. Okay, so it's just isolating quantities. So let's cross multiply first. If I cross multiply, boom, boom, I got 12RQ is equal to 35PS. And then we're trying to express Q. Okay, so then I'm going to isolate Q. So I'm going to divide both sides, hold on one second, by 12R. Right, divide by 12R, that's what I'm doing. And that's pretty much it. Nothing simplifies. 35, 5, and 7, and this they have no common factors. So 35 PS over 12R. Boom, B is the winner, done. 11, let's go. The table shows 4 values of X and the corresponding values of H of X. There's a linear relationship. Okay, so we're trying to find the slope, and then a function notation, H of 2. So first of all, I got this great table. I like to flip it into coordinates. This is arbitrary, that you don't have to do this. This is how I like to do it. And I stack the coordinates, and I'm going to subtract down to get the slope. 48 minus 80 is negative 32. 4 minus 8 is negative 4. So we got a slope of 8. So A is 8. So now we're going to plug that in. And we got 8x plus 16 is now my h of x. Oops, is now my h of x. And we want h of 2, so now we plug and chug. 2 goes in, 2 times 8 is 16, plus 16 is 32. That's the answer. Okay, hold on. Let's make sure we didn't make any mistakes. So 8x plus 16. Plug in 4, 32, 48. Plug in 8, 64, 80. Plug in 12, 96. Okay, that's confirmed. So it is 8, and then you plug in 2, 16, 16, 32. Boom, done. Okay. Number 12. The given expression is equivalent. Okay, those parentheses aren't doing anything, okay? And this is the format we want to get it into. So when there's just pluses around it, we can get rid of them. And then we can add common like terms. I'm not going to rewrite the whole thing. I'm just going to add the terms. So 2 plus 3, that's 5y cubed. Negative 5 plus 1 is negative 4y squared. 4 plus negative 4 cancels out. So there's the answer. And then it says, or there's the expression, excuse me. Then it says, what is P plus Q? P is this coefficient. Q is this coefficient. Don't forget the negative, right? Because it's negative, because of the minus, it's negative 4. So we're adding those together. 5 plus negative 4 is 1. 1 is the winner. Done. Okay. 13. When x5 is a solution to the system of inequalities. Which of the following could be the value of x? Oh, x5. Wait. X5 is a solution to the system of inequalities. Let's see. Okay, I'm going to plug and chug and just like see. So 5 is greater than or equal to x minus 3. Oh, wait. I can just plug in these values. What am I doing? So, and then, oh, well, here, let's write that one out too. 5 is less than negative 2x plus 10. And then now we just see which one works. Negative 1 would be 5 is greater than negative 4. 5 is, no, not negative 1. Do they have the cancel thing? They do. Amazing. Okay, that part I didn't know, but it's awesome. Okay, 6, 12. So 5 is greater than 3. 5 is less than negative 2. Wait a minute. I just canceled this out. Hold on a second. Wait, what am I doing? Hold on. Negative 1 is 5 is, no, that was right. What am I saying? 5 is greater than negative 4. 5 is less than 12. A does work, but hold on. Let's check the rest. Okay. 5 is greater than 3. 5 is less than negative 2. Out. That one's wrong. Wait, did I write this right? Yeah. Okay. 12. 5 is greater than or equal to 9. 5 is less than negative 4. So that's out. And 24. 5 is greater than. That's false, definitely. Okay, I think we got it. Should I check? Let's just go on. Let's move on. I think we're good. I could graph these, and then I could plot that point. It's fine. Let me just double check mentally one more time. 5, negative, so what did we choose? Negative 1? 12, 5 squared. Okay, yeah, I'm happy. 14, program processes 100,000 lines of code per hour. Processing rate decreases 15% every 2 hours. Okay, this is an exponential equation, so I guess let's just create the equation. So we're starting at 100,000. Decrease it by 15% would be 1 minus 0.15, which is 0.85. And then every 2 hours. So it's like x over 2, if x is hours. So you plug in 2, that'd be, whatever. That would give you 15% less. So now we can plug in 8 into this equation and quickly solve it. So let's see, 100,000.85 to the 8 over 2, which is 4 power. 52,200. Let's see if that's there. Okay, it's that one. Boom. 15. Wait, did I skip something? No. All right, cool. Oy, this is a big question. Let's zoom out a little bit. Okay. The graph represents function f of x, models the plant species, and y in 100. So y is the, plant species in 100. So that's 200, 300, 400. And number of years since the conservation program began. So this is right when it started, 1 year, 2 years, 3 years. So obviously the plant species is going up. What's the best interpretation of f of 10 minus f of 0? Okay, well, first of all, what is f of 10? That is the function value when x equals 10, which is 800, I guess. And then f of 0 is 200. So it is 600. But what I would say is it ends with 800 species. It began with 200. So I would say that's the amount of species that has changed or increased in this case over that 10-year period. It's not 6, it's 600. The estimated total plants increase in national park during 10 years. Yeah, 600. So I would say it's that. Estimated number of plants in national park being in the conversation. No, that doesn't make sense. That's the initial value. That would be just f of 0. Okay, so B is the winner. It's pretty tough actually it's a nice difficulty for module 1, I would say. Okay, so we got this one. Which expression is equivalent to where x and y are positive? Okay, the fourth root. So what I'm going to do is I'm going to turn this into fractional exponents. So we got x, and that is the power, so that's the numerator. The 4 is the radical, so that's the denominator. Same with y. It's to the 22, still over 4. And that reduces to 11 over 2. 11 over 2. And then, yeah, it's this one. Because they just factored out the 11 over 2, which you can do. You can just be like, cool, the whole thing is to this. So C is the winner. Let me just make sure I didn't make a mistake. Fourth root. Yeah, that's good. Okay, 17. The number of people attending a conference increased by 20% from day 1 to day 2. If the second day's attendance is R times the first day's attendance, it's 1.2. Okay, these questions, let me explain what they're getting at. And I've seen these actually quite a bit now on some of the more recent US versions as well. I think this is a great play by SAT Crash Course to include this, because I see the College Board, and what they're doing is they're just wanting you to make sure, hey, 20% of something, you know that's 0.2 times that thing. When we're talking about an increase of 20% by straight multiplication, otherwise you can take 20% and add it, right? But if you're doing it by straight multiplication, you're multiplying by 1.2. If you're doing a 40% increase, 1.4. If you're doing a 110% increase, 2.1 is what you're multiplying by. You're multiplying because you're doing 110%, 1.1 plus 1, okay? And they've been testing on this a lot, so be mindful of that. Okay, which of the following has infinitely many solutions? Look, we can graph them all, too, in Desmos and see which ones they overlap. But bottom line, it's not A, because they have to be the exact same. That obviously is different. This one, hold on. Would this one work? If we divide by 3, 5x. Let me write it out. 5x minus 2y equals 6. And then divide this one by 2. 2y equals 5x minus 6. Wait, it looks promising. Hold on. That's right. It's B. I'll show you why. Look, because if you minus 2y, you get 5x minus 2y, and then you add 6. And look, it's the same thing. 5x minus 2y equals 6. 5x minus 2y equals 6. And then we can, look, we'll graph it real quick just to be safe. Check it out. 15x minus 6y equals 18. 4y equals 10x minus 12. And look at that. Look, they're right on top of each other. That means infinitely many solutions. Infinitely many solutions means where do they intersect or overlap? And they overlap forever and ever, right? It's a line, and the whole things are the same. So, yeah, we don't really need to check the rest. I mean, we have the time, but it's fine. We confirmed it for sure on the calculator. First term of the sequence is 7. Hold on. We got a little geometric sequence happening. It's 7. Each term after that is 6 times the preceding term. So 42, then 2, 42, 52, and so on. If B represents the nth term of the sequence. Okay, interesting. This is a geometric sequence formula question, okay? But there's a workaround. If you don't know the formula, I just showed you how to get the first 3 terms. It says the first one is 7. The second one is this. Okay. So the nth term of the sequence, that means I should be able to plug in 1 and get 7, 2 get 42, 3 get 252 for the correct answer, okay? This is the correct answer, B, and I'm going to tell you why in 2 ways, okay? Number 1, we can plug and chug and verify. If I plug in 1, 1 minus, and pretend I didn't know that. If I didn't know that, or if I didn't just spot that, you could just plug in, go the way down, right? Plug in 1 here, and we get 42. Wrong. We're supposed to get 7. Plug in 1 here, you get 42. Wrong. Plug in 1 here, you get 6. Wrong. So I've already figured it out. It's B. But how did I know that this was correct so quickly? Because this is a geometric sequence format, which is the initial value 7 times the what's it called? The common ratio. Don't have to know that. It's just the multiplier. And the multiplier is 6. And then it's always to the n minus 1. But now we can verify. Plug in 1. 6 to 0 this is 1 times 7 is 7. 2. 6 to 1 is 6 times 7 is 42. That's correct. Boom. 3. 6 squared is 36 times 7 is 2 times 42, 252. 252. Well, it should have been. But yeah. So B is the winner. That's how you do it. 20. Minimum value of Z. Okay, watch what I'm going to do here. I'm going to literally write this out as I'm reading it. The minimum value of Z, meaning Z is greater than that or equal to. Minimum value of Z is 10 less than 3 times another number P. Boom. We got it. We just did it. And it's B. So if you read it and write it just like how I did, it's not so bad. Let me just see if there's a way I can think of to check this. Let me think. The minimum value of Z is 10 less than 3 times n. So that should be the minimum value. So it should be, so that's telling us like, yeah, it's at least this, not it's greater or it's less than this. Because it can be greater than all that. So, and let's say 3 is 10. I don't know. 3 is 10. So 3 times 10 is 30. So that's 20. So Z would be at least 20 or greater. I mean, this feels right to me. I don't know how else to check it because we're just literally putting that language into an inequality. And if we've done that correctly, if we feel confident about that, we should be good to go. You know, the last thing I'll say is, you know, this 10 less than 3 times another number P. Sometimes people be like, oh, shouldn't that be 10 minus 3P? Shouldn't that be D? Think about it like this. If I said 10 less than 100, what would you say? You would say it's 90. If I said 10 less than 100, you instinctively know it's 90. Well, that's 100 minus 10. What's 10 less than 1,000? 990. So since you know instinctively that if I say it that way, you know what to do, right? If it's a non-variable. If you're trying to put together an equation, think about it the same way. 10 less than 3P. Oh, it should be 3P minus 10. That's it. Okay, 21. We got so much time. We're doing great. 2 questions left. The side lengths of... let's draw it out. The right triangle L, M, and N are given. Right triangle. 2 right triangles. We got a similar. Hold on. It doesn't say what is the right angle. Oh, well, we can tell because here, NL is 148. That's the hypotenuse. And then MN, so MN is 140. So no, what am I doing? MN, that's MN is 140. NL is 148, and then this side is 48. Okay, cool. That works. And we can do the same thing here, and it says it corresponds, it's similar to PQR. LMN PQR. All right. What is the sign of P? So look, here's the deal. When we have, these are great questions, by the way. The College Board loves these. If you're taking sine of P and these are similar, it's the same as sine as L because the angles are the same. And that's what we care about with these trig functions, not the actual size. So you might be like, wait a minute, I don't know these side lengths, which you don't, but you don't need them. You know, you're good to go. So what is sine of L? Just remember SOHCAHTOA. Let me write it out. Sine is opposite over hypotenuse. So sine of L, opposite over hypotenuse. So it's 140 over 148. And that reduces, does divide by 4? Wait, hold on, let's divide by 2 first. 70 and 74, 35 and 37. So that's the reduced version. Boom. Okay, let me make sure I didn't make any mistakes. Hold on, LM, so sine of P is the same as sine of L. That makes sense. And let me go back to this. LM is 48. MN is 140. L and NL is 148. Sine of L, opposite over hypotenuse, 140 over 148, 70, 70. Yeah, I feel good. I'm checking everything so thoroughly because I can. At this point, when you have the time, this is what you should be doing. You shouldn't put your thing down and just chill, right? This is what I would do. This is what I do when I take tests for real, is I'll check it as much as I can with the extra time. You may not have this much extra time, but if you do, why not? Then you go on and feel so confident. Okay, the graph of the given equation, okay. Translated 3 units in the xy plane. What is the x coordinate? Okay. I'll show you a couple ways to do this, all right? Number one, I can just calculate the x-intercept right now. What is the x-intercept? The x-intercept occurs when y is equal to 0. Why? Because it's when it hits the x-axis. And notice that's when we're at a 0 point for y. So one of the easiest ways with an equation is just plug in 0 for y. So that goes away. We're end up with 4x equals 12, and then x equals 3, okay? So then the current x-intercept is 3, 0. Shifting it to the right by 3 units would make it 6, 0. And so therefore it would be 6. Okay, that's one way. The other way, or another way, would be 4x plus 5. When you shift it by 3 units to the right, you're minusing 3 from the x value, okay? And then we can still, oh wait, hold on, plus 5y equals 12. Still zero this out, then you get 4x minus 12 equal, wait, no, that didn't work. Hold on a second. Wait, when we translate it, can't you go x minus 3? Why didn't that work? Hold on. 4 times x minus 3 equals 12. Hold on. Does that need to be in y-intercept form? Hold on. Because then that just gave me 0. 3 units. Oh, what am I doing? Yeah, 3 units right. Oh, now I'm getting a conflicting. That doesn't make sense. Hold on. 3 units to the right should be x minus 3. Oh, yeah. What am I doing? I literally just made a arithmetic mistake in my head. I was like subtracting these two and getting 0, and I was like, that's not right. But you would add 12, not subtract 12. Excuse me. So then you get 4x equals 24. X divided by, or both sides divided by 4 is 6. All right. So anyways, that confirms 6. So it still should be 6. Okay. And then we got this trusty tool that we don't want to forget. This might be the easiest way. Look at that. There's my x-intercept, 3, 0. Translated 3 right 3 units, boop, boop, boop. It's going to be at 6. So that's pretty much it. Okay. I don't believe we're going to be able to see the grade. But we're going to pause here because we're doing module 2 tomorrow. Also, my voice is dying. So I need to take a break right now. But that's it. Here, wait. Can I exit? Save answers. Okay. So we're going to save answers. I'm assuming, yeah. So there's no score that we can see yet. But tomorrow, when I do module 2, we'll see if I got anything wrong. If I did, I apologize in advance, and we'll just we'll review and we'll figure out why. No problem. I'll still explain it. But that's pretty much it. All right, let's open it up to see if we got any questions here. Okay, people are asking, what is this from? This is from the SAT crash course. You can see it right there. So again, the link to access this website is in the description below. These tests are for sale. This is a sponsor, okay? And we have partnered up because I do think their tests are really good. And I thought the interface is great too, right? This is the second one that I've taken of theirs, but it just, I don't know. I like it, and I think they do a good job. And I think a lot of people don't get it right. But this feels so right. It feels so much like the College Board. So that's where it is. If you're looking for additional practice for the digital SAT this Saturday, that's where you can check it out. Let's see. 35 out of 37. Oh, Preeta, that's that one question I was working on. It is not the same as the Blue Book. These are different tests. These are, they have 20 unique tests that they've created. Oh, Preeta, yeah. So sorry. Yeah, I should have made that clear at the beginning, I think. Okay, let's see. For no, when are you going to start December session on YouTube? Start December session? Do you mean prepping for the December one? Probably in November. Okay. Okay, guys, I'm gonna wrap it here. I hope you guys found that helpful and useful, and this was amazing. This was really fun. If you did like this video, make sure to click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. And I'm going to post the time soon for when we're doing the stream tomorrow. And then we're going to be doing something on Friday as well for the day before the test. So that's the big day. That'll be important. Thank you guys so much for joining, and I'll see you in the next video.